In this lesson, we're going to look at adding and subtracting rational expressions where the denominators are opposites. So let's review what we mean by opposites. So for example, again, this is going to be a quick review. So the opposite, and remember another word for opposite is the additive inverse. So the additive inverse. Okay, so the opposite or the additive inverse of, and then let's look at part A. So let's say we had 7. So we all know that the opposite or the additive inverse of 7, and the answer is -7. Okay, now so when you add two numbers that are opposites, their sum is 0. So that's the idea here, the additive inverse. So 7 plus a -7 is 0. Okay, now if we look at something a little bit more complicated, like let's say negative 3x, the opposite of a negative 3x is a positive 3x. And so notice that when you're dealing with opposites, the signs are the only thing that's different. So a negative 3x, the opposite is positive 3x, or the additive inverse is positive 3x. So what you're going to look at, though, in this lesson are where our denominators are either a binomial or a trinomial. So for example, if I have 7 minus 2x, the opposite of 7 minus 2x, the answer is, remember, the sign just changes. So 7 becomes a -7, negative 2x becomes a positive 2x. And again, you can always rewrite this as 2x minus 7. Just make sure you understand that those mean the same thing. Okay? D, so let's suppose we had 5x plus 2. So it is possible that your denominators, the signs will be the same for your terms. So the opposite of 5x plus 2, the answer would be -5x minus 2. Or if you want to, you can write it as -2 minus 5x. Does not matter. Again, make sure you understand that those two mean the same thing. All right. And then E, let's suppose we had a trinomial. Let's suppose we had x squared minus 3x plus 2, let's say. So the answer, again, all you do is just change the signs. So x squared becomes negative x squared, negative 3x becomes positive 3x, and then positive 2 becomes -2. All right, so the opposite of x squared minus 3x plus 2 is negative x squared plus 3x minus 2. So remember, when you add two expressions that are opposites of each other, their sum is 0. So hence the idea of that additive inverse. The other thing I want to review is this, and this is going to be important. So let's review adding some fractions. So number 1, we have 3/8 plus 5 divided by -8. And so I want to talk about this -8. So first of all, do you notice that 8 and -8 are opposites? Okay, so they are opposites. Now, there are different ways of writing this, and that's going to be important in our discussion. So there are different ways of writing what you see here. So do y'all agree? Do y'all agree that that expression is the same thing as saying this? 3/8 plus 5. And I want you to understand that -8 means the same thing as -1 times 8, right? Okay. Do y'all also agree that see how the denominator I am multiplying by -1? Well, if I wanted to, I could have rewritten it where that -1 factor is in the numerator instead. So I have 3/8 plus a -1 times 5 divided by 8. So make sure you understand that this fraction is the same thing as this fraction. I just wrote the factor of -1 instead of the denominator, I put in the numerator. All right. And now, also, I want you to think about this. Do y'all agree? Okay, so that's one of the first things I wanted you to look at. The second one is, let's suppose we had this. Suppose we had 1/5 plus -3 divided by 5. All right. Now, I know that the denominators are not opposites, but I want to talk about this right here. Do y'all agree that 1/5 plus a -3/5 means the same thing as 1/5 minus 3/5? Y'all agree with that? Okay. So instead of remember subtraction I can change to adding the opposite. So 1/5 subtract 3/5 means the same thing as 1/5 plus the opposite of 3/5, which is negative 3/5. So when we start talking about the content that we need for this part, this is going to be important. This is going to be one idea, and this could be another idea. All right. So there are different ways to think about how you're going to approach dealing with adding, subtracting rational expressions with opposite denominators. Now, the other thing I want to talk about with this before we go on is this. Suppose I had 2/3 plus, let's say 1 divided by, I'm not going to use 1, let me use 4. 4 divided by negative 3. Okay, do y'all see that one right here, number 2, 1/5 plus negative 3/5, I could have written it as 1/5 minus 3/5. All right, see where the numerator is negative? Here, the denominator is negative, but the same idea is the same idea. So that can be the same thing as saying 2/5 minus 4/3, okay? Because subtraction, I can change to addition problem, and basically you're saying 2/3 plus the opposite of this, and the opposite of 4/3 is a negative 4/3, which is what you see here. Just so happens that the 3 is negative instead of the 4. No big deal. Okay, now let's see. I think there's one more I want to do. So let's look at number 4. Number 4. Suppose I had this. Now all of these problems I start out with addition. So let's look at a subtraction problem. So we're going to look at the same problem here, but instead of addition, we're going to look at subtraction. So 2/3 subtract 4 divided by negative 3. All right. So do you see that right here? This right here became a subtraction problem. So 2/3 plus a negative 4/3 becomes 2/3 minus 4/3. Okay. So you see this right here. I want you to understand that 2/3 subtract a negative 4/3. That's what you're thinking about. All right. This is important. 2/3 subtract a negative 4/3. This and this mean the same thing. Means the same thing. So remember, you change the subtraction to addition. This means the same thing as 2/3 plus the opposite, so that's 4/3. So whenever you're subtracting a negative fraction, it becomes an addition problem. So 2/3 plus the opposite of this, which is a positive 4/3 instead. Okay, so that's going to be important. So I want you to understand that this right here means 2/3 plus 4/3. All right, so just like when you were subtracting a negative fraction, this became I could write a subtraction problem. This, you are subtracting a negative fraction, I wrote it as an addition problem. Makes you understand why, though. Don't memorize anything because it makes no sense to memorize. You have to understand why that's true. So this is this, and then just remember, you're adding the opposite. Hence the idea that additive inverse. Okay? All right, now let's look at some problems. So it may be that I may have to do 2 parts of this lesson, so that way it doesn't get too long. All right, so this will be, let's call this part 1. So this will be part 1. So part 1, let's look at these examples. All right, so number 1, so again, it's going to either say, the directions will either say perform the indicated operations, or it will say add or subtract. So I'm just going to put add, subtract, because some problems will be an addition problem, and some problems will be a subtraction problem. Okay, number 1, we have 5x divided by x minus 3 plus 3 divided by 3 minus x. Okay? All right, now, notice that these two fractions, these two rational expressions don't have the same denominator. Remember, in the previous lessons, in order to add or subtract rational expressions, the denominators have to be the same. They're not the same. But what do you notice about those denominators? You notice that those are opposites. Okay, those are opposites. So here's the idea, and then think about this carefully. So I'm going to rewrite this. I'm going to rewrite this so that way it looks like this right here. It looks like where you can actually see 8, negative 8. So in other words, I'm going to factor out a negative 1 from here. So I get 5x divided by x minus 3. Notice the steps. That's important. Plus 3 divided by negative 1 times, okay, now, do y'all agree? You see, when I find, I'm going to go do the work right here so you can see this. So I have so I have 3 minus x. And then I'm going to factor out a negative 1. That's what I'm trying to do here. Negative 1 times the negative 3 is a positive 3. And then a negative 1 times a positive x is a negative x. But what I want you to recognize is that this is this, right? So whenever if you notice that those are opposites, and they are because the signs are different in each case, the terms, then that means I can rewrite this as this right here as a negative 1 times this factor. So this is x minus 3, and you know that's true because of this. This right here means the same thing as negative 3 plus x means the same thing as x minus 3. Okay, so whenever we do the problems, whenever I factor out a negative 1 to save some time, I'm just going to say negative 1 times this. Negative 1 times this will give me this. Okay? All right. Now, what I want you to recognize, and that's the discussion we had here, this idea here. So what I want you to recognize is this. Do y'all agree? Do y'all agree that where I have that negative 1 factor in the numerator, I can write in the denominator, where I have the negative 1 factor in the denominator, I can write in the numerator. So in other words, I can write this as 5x divided by x minus 3 plus the negative 1 times 3 divided by x minus 3. And so now you see those denominators have the same factor. So all I did was just use some properties to get me to this point where they're actually the same thing. And then this is just a negative 3, so that becomes 5x divided by x minus 3 plus the negative 3 divided by x minus 3. Now, at this point, if you want to, you could think of what we talked about here. So when you have 1/5 plus a negative fraction, negative rational expression, you can rewrite it as a subtraction problem. Where you have an addition problem, you're adding 2/3 plus a negative fraction, you can write a subtraction problem. Okay? Or where you have a subtraction problem, you have 2/3 subtract a negative 4/3, it becomes 2/3 plus a positive 4/3. So those ideas you can use here. You don't have to, because most students know that 5x plus a negative 3 means the same thing as 5x minus 3 divided by x minus 3. So remember, from previous lessons, whenever the denominators are the same, that means now you can write as one rational expression and just rewrite the numerator. Now, don't write the numerator as this. Don't say 5x plus a negative 3 divided by x minus 3. Don't do that, okay? Because you all know that 5x, even though it's true, you all know that 5x plus a negative 3 is 5x minus 3. So that's the answer we want, okay? Now, what I want you to notice is this. You don't have to go through this process. As long as you understand what's happening, you can go from here, right here, you can go from here to this, and it's up to you. So you can say, all right, well, I'm adding a negative rational expression here. Okay, see that negative 1? So using this idea here, this is going to become a subtraction problem. And so I have 5x divided by x minus 3 minus 3 divided by x minus 3. And then notice, I want you to recognize that this and this are the same thing. Okay? That's important. This and this are the same thing. And that kind of makes sense because of this. 1/5 plus a negative 3/5 means 1/5 minus 3/5. Okay? And then that becomes this. So there are multiple ways to go from here to this answer. Okay? All right. Number 2. Oh, and by the way, so the next step would be, remember, the next step, once you write it as a rational expression, then you got to simplify. But I can't factor either numerator or the denominator, and then there are no common factors. So we're done. So that's the answer. Number 2, we have 7 divided by x minus 5, subtract 3 divided by 5 minus x. All right, so notice in order to subtract two rational expressions, the denominators have to be the same. They're not. But what do you notice about those denominators? You notice that those denominators are opposites. Okay, so that means this. That means, and actually do this. That means that this, I'm going to leave the first rational expression with x minus 5, and I'm going to rewrite the second rational expression. I'm going to rewrite the denominator as negative 1 times, and remember, Negative 1 times a negative 5, remember that's what you're saying. Okay, so you're saying negative 1, so that's going to equal negative 1 times a negative 5 is positive 5. And then negative 1 times a positive x is a negative x. But I want you to recognize that this means this. And I rewrote it like that because that's what this is. So that becomes negative 1 times x minus 5. All right? And now I want you to recognize this. You see how you have a subtraction problem? You're subtracting a negative, right? All right, so if you need to rewrite a little bit further, you can. It's up to you. So I want you to notice this. So, oops, that's minus. So I'm going to rewrite this negative 1 factor in the numerator. All right, so that's negative 1 times 3 divided by x minus 5. And so now you see they're the same. Okay? So that's going to become, I want you to also notice that this is a negative 3, right? So since they're the same factor, you can write it like this. Write it as one rational expression, and then you just say this: 7 subtract, and negative 1 times 3 is a negative 3. But 7 subtract negative 3 means 7 plus 3, right? Divided by x minus 5, and so that's 10 divided by x minus 5. So that's one approach to take from going from here to here, okay? The other approach, remember, is this. So just knowing that I am subtracting, see that negative factor? So subtracting a negative 1 factor becomes 7 divided by x minus 5 plus the positive 1 factor. So in other words, that becomes this. All right, and notice that this and this mean the same thing. This and this mean the same thing. Okay? This and this mean the same thing. So that becomes 7 plus 3 divided by x minus 5, which is 10 divided by x minus 5. All right, now again, once you get to that point, you need to simplify. I noticed that I can't factor the numerator to the denominator and reduce common factors, so I'm done with number 2. All right, so notice the important thing at each part as we go through this is this part right here. Recognizing that those are opposites and then rewriting this one so that way, and I would always rewrite the second one, the second fraction. So that way you get that negative 1 factor that you can actually see, okay? And then you can go from here either using this approach or using this approach, okay? All right, number 3. So number 3, we have x squared plus 3x divided by x minus 4, and I'm adding x squared plus 12 divided by 4 minus x. Okay, now I want you to notice the difference between number 3 and numbers 1 and 2. So if you go back to 1 and 2, notice that the second rational expression, this numerator was a monomial factor, 1 term. Number 2, that was a monomial factor, 1 term. So our work wasn't that difficult. It was fairly easy to deal with, our discussion. Here, though, that's not a monomial factor. It's a binomial. So we need to be a little bit careful when we factor out the negative 1 and then go from there. All right, so listen carefully to how we're going to discuss this. All right, so I'm going to leave the first rational expression alone, so I'm just going to rewrite it. And again, remember, in order to write these two into one rational expression, the denominators have to be the same. They're not, but they're opposite. So that means I can factor out a negative 1 from here, and it's going to look just like that one. So I'm going to get x squared plus 12 divided by negative 1 times, and remember, negative 1, when I factor out a negative 1, I want you to understand that negative 1 times this gives me this. So 4 minus x, when I factor out a negative 1 times a negative 4 is 4, negative 1 times a positive x is a negative x. And so negative 4 plus x means the same thing as negative 1 times x minus 4, which is what this is, okay? All right, now, you see this negative 1? You remember a while ago, one of the things we did was we took that negative 1 factor and I wrote as a factor in the numerator. All right, so you got to be careful though, because that's a binomial. So the way you're going to do this, if you go that approach, you're going to say x squared plus 3x divided by x minus 4 plus, all right, so my denominator is going to be x minus 4 because I'm rewriting the negative 1 factor. I'm going to put in the numerator. But you got to say negative 1 in parentheses this numerator, because all of those terms are being multiplied by negative 1, okay? And then you would distribute the negative 1, and so you get, let's see, you're going to get x squared plus 3x divided by x minus 4 plus a negative x squared minus 12 divided by x minus 4. Okay? So once you get to that point, so you distribute the negative 1. Once you get to that point, the rational expressions have the same denominator, so I can write this as one rational expression, right? And just adding, see, addition is easy to deal with, just adding just combining like terms. So x squared plus a negative x squared, that's 0. 3x and a negative 12, well, that's 3x minus 12. So make sure you understand that the numerator is this. Then the next step, remember, once you write it as one rational expression, the next step is to factor. So I can factor out a 3 from the numerator, and I get 3 times x minus 4 divided by x minus 4, and then you reduce. And I can reduce common factors here. The x minus 4s divide out. Make sure you remember you get factors of 1 in their place, and so the answer is just 3. Okay, so just remember that this was the part you have to be careful with. So when you take this factor, negative 1 factor in the denominator, write it in the numerator, all of these have to be multiplied by negative 1. So that's why I put that in parentheses. And if you distribute, you get this. Okay? But I want you to also note this. See, you can go from here to this if you want to. So in other words, just using this fact that whenever you're adding a rational expression and there's a negative 1 factor, you can write it as a subtraction problem. Okay, so plus, many students think of it as plus a negative, but you got to understand why that's true. So plus a negative is going to be a negative. All right, so if you want to, you see where you have plus and then you have that negative 1 factor in this rational expression, then I can write this as this. Now notice I'm going to write this. Okay, so that's going to become x squared plus 3x divided by x minus 4, and I'm subtracting, so this right here becomes a subtraction problem, x squared plus 12 divided by x minus 4. Okay, so all I did was I took this negative 1 factor, so I'm adding a rational expression with a negative 1 factor, and I'm taking that right here and changing it to a subtraction problem. The rest stayed the same. And then now this goes back to our lesson on subtracting rational expressions with the same denominator. Now the way I would do that, remember what we did was, since I still have a subtraction problem, then and by the way, these two rational expressions have the same denominator, so I'm going to write this as one rational expression. But notice this is going to become x squared plus 3x minus, in parentheses, remember all that? Since I have more than one term, x squared plus 12. And now distributing, I get x squared plus 3x. The opposite of x squared is a negative x squared, and the opposite of 12 is a negative 12. But I want you to notice something. You see this right here, that negative 12, the negative x squared and negative 12, where we distribute that negative 1? That's what this is, right? See this right here? Distribute the negative 1. That and that are the same thing. Even though you're going to rewrite it, all of these are connected. So this part is this part here. You see that? All right. So it's up to you how you approach this, but all of these are connected. Rewriting it this way means the same thing as rewriting this way, and you can see where they're connected. All right. And so x squared and negative x squared, 0. 3x and a negative 12 I can't combine, but so I'm going to rewrite it as 3x minus 12. And then again, I can factor out a 3. So I get 3 times x minus 4 divided by x minus 4, and those divide out. And you just get 3. All right, so multiple ways of doing these problems where you have the opposites. All right, so that was number 3. Let's look at number 4. Number 4, we have, all right, number 4, we have n divided by n plus 5 plus a negative 5 divided by negative n minus 5. All right? Okay, so I want you to notice that these two rational expressions I'm adding. All right, and before I can combine this into one rational expression, those denominators have to be the same. I need for you all to also recognize, and you have to recognize this, that the opposite of n plus 5 is negative n minus 5. So the additive inverse of n plus 5 is negative n minus 5. Notice the signs are different. So that means that these are opposites, so therefore I can factor out a negative 1 from this denominator. And so let's go ahead and do that. So first thing you should always do is factor out that negative 1, step number 1. All right, so notice I'm writing everything else the same. I'm going to rewrite this as negative 1 times, and remember, based on our experience, notice that what's going to be here will be this. Because negative 1 times n is a negative n, and negative 1 times a positive 5 is a negative 5. Okay? Now, you see this right here? It's easy well, okay, so you can do one of two things. You can think of this as adding, you see where you have that negative 1 factor? So this would be a subtraction problem. Or if you want to, you can rewrite this negative 1 factor in the numerator. It's up to you. It does not matter. So I get n divided by n plus 5 plus, I'm going to rewrite in the numerator. So this is going to become a negative 1 times a negative 5 divided by n plus 5. So I took the negative 1 factor and I put in the numerator. And so negative 1 times a negative 5 is a positive 5. So this becomes n divided by n plus 5 divided by n plus 5. See that? And then now I can write this as one rational expression because the denominators are the same. And the numerator is just n plus 5. And then notice that those two factors are identical. So they divide out and you're just left with 1. So the answer is 1. All right, number 5. That's number 5. We have, let's say we had 5, 5n divided by n squared minus 9. And I'm subtracting 15 divided by 9 minus n squared. All right, so 5n divided by n squared minus 9, subtract 15 divided by 9 minus n squared. Okay, so I'm subtracting two rational expressions. They don't have the same denominator, but I do notice that the denominators are opposites of each other. They're additive inverses. N squared, negative n squared, negative 9. The opposite of negative 9 is a positive 9. So they're opposites. So that means, and always use the second rational expression, that means I can factor out a negative 1 from this denominator, and then that factor in parentheses will be the same as that one. Okay, so I get 5n divided by n squared minus 9, subtract 15 divided by, all right, so remember the first thing, and I actually do this, first thing is to factor out the negative 1. So I get negative 1 times, I want you to understand that negative 1, and I'm going to write it again. So I'm taking this, I'm going to factor out a negative 1. Negative 1 times a negative 9 is a positive 9, and then a negative 1 times a positive n squared is a negative n squared. But do y'all understand that negative 9 plus n squared, remember addition is commutative, so the order in which you add does not matter. So negative 9 plus n squared is n squared minus 9. And that's what this is. All right, so that's why I was saying that when you factor out a negative 1 from here, that negative 1, when you look at your factors, this factor will be the same as this one. And always check. This, when you distribute, that gives you this back. Now, what I'm going to do now is I'm going to, now there's one of two things you can do. You see where you're subtracting a negative 1 factor? So if you want to, you can write this as an addition problem. All right, so here's the approach. So one path is to go from here and think of this as subtracting a negative 1 factor as an addition problem. So that becomes 5n divided by n squared minus 9 plus 15 divided by n squared minus 9. Okay, that's one way. So that's where we're looking at this part here, the negative 1 right here, and that becomes this. All right, and then now I have two rational expressions that I'm adding with the same denominator, so that way I can write this as one rational expression, and I get 5n plus 15. And the next step, remember, is to factor. So I can factor out a 5 from the numerator. So I get 5 times n plus 3. In the denominator, that's the difference of 2 squares, so you get n plus 3 times n minus 3. And then notice I can factor out the n plus 3's. Remember, factors the 1 in their place. And so therefore I get 5 divided by n minus 3. Okay? So that was one way, one path. The other path could have been this. So I'm going to rewrite this over just to show you. And so remember I had that in the denominator, I had a negative 1 times n squared minus 9. So remember the other path is where you take that negative 1 factor and you bring it to the numerator. So in other words, I'm saying this is going to be 5n divided by n squared minus 9 minus, and then negative 1 times 15 divided by n squared minus 9. See that? So I put the negative 1 factor in the numerator. And negative 1 times 15 is a negative 15. So here's what we have. We have 5n divided by n squared minus 9 minus a negative 15 divided by n squared minus 9. Okay, now I can write this as one rational expression. So this will become 5n minus a negative 15, right? But remember, subtracting a negative means adding the opposite. So this becomes 5n plus 15 divided by n squared minus 9. And so notice that this right here, see how I wrote this like this? That's this right here. Okay, so 5n plus 15. So try and make sure you can see all of the how these paths are connected. And then you would reduce this, you would factor and then reduce just like we did here. So this becomes 5 times n minus 3 divided by n minus 3. I'm sorry, n plus 3, excuse me. N minus 3 times n plus 3, the numerator is n plus 3. Then the n plus 3's divide out, and you get your answer of 5 divided by n minus 3. All right, so different paths you can take. It's up to you. But it's a good idea to know the different paths. Just know how to deal with all of this. Okay, number 6. Let's suppose number 6 we had this. We have 3k divided by 6k minus 12, and I'm subtracting 6 plus 5k divided by 12 minus 6k. All right, now again, you see where I'm subtracting, and this is not a monomial, so I got to be careful. You have to be careful. All right, so that's where we're going to do some work on the side to help us. But I want you to recognize I am subtracting two rational expressions. The denominators are not the same. Remember, you got to make sure the denominators are the same before you can add or subtract. They're not the same, but I do notice they're opposites. So that means I'm going to factor out a negative 1 from here. First step is to always factor out a negative 1 from here if your denominators are opposites. So I'm going to get 3k divided by 6k minus 12, subtract 6 plus 5k divided by negative 1 times, and remember, this right here, when you factor out a negative 1, it's going to be negative 1 times this. All right, so I'm just going to rewrite what I see here and then just double check. Negative 1 times 6k is a negative 6k. Negative 1 times a negative 12 is a positive 12. All right. Now, there's one of two things you can do. Well, one of several things you can do. So one path is to recognize this. All right. And so notice that sometimes, and that's why it's important to know both. Sometimes it's easier to do one path over another. So you see where I'm subtracting this rational expression and I have that negative 1 factor. Well, remember, this right here becomes an addition problem. So this becomes, so one path will be this. So this becomes 3k divided by 6k minus 12 plus 6 plus 5k divided by 6k minus 12. Okay? And then notice how easy this becomes now. So I'm adding two rational expressions with the same denominator. So I'm going to write this as one rational expression. And then notice I'm just adding. So adding the two numerators is easy. You just combine like terms. So 3k plus 5k is 8k, and then plus 6. All right, and then let's factor and then reduce if we can. So this will become, it looks like in the numerator I can factor out a 2, right? So you get 2 times 4k plus 3. The denominator looks like I can factor out a 6. I get 6 times k minus 2, right? And then can I Can I reduce? Yeah, I can reduce a 2 and a 6, and that's about all I can do. So 2 into 2 is 1, 2 into 6 is 3. So the answer is going to be 4k plus 3 divided by 3 times k minus 2. And again, leave your answer in factored form. Don't distribute the 3. All right, so that's one path. You saw that one path? All right, now let's look at the different path. So the different path will be this. So I'm going to go ahead and rewrite this problem right here, and then we're going to look at that other path. So 3k divided by 6k minus 12, subtract 6k plus 5, divided by negative 1 times 6k minus 12. All right, so the other path is where you take this negative 1 factor where it's in the denominator and write it in the numerator. So that's the other path. So that would be this. You would say 3k divided by 6k minus 12, subtract, and then in the numerator I'm going to say negative 1. Now remember, that's a binomial. That's more than one term, so put that in parentheses, just like this. Okay, that's important. And divided by 6k minus 12. All right, now at that point, you can distribute just like this. And so you get 3k divided by 6k minus 12, subtract, and then the numerator becomes negative 6k minus 5, right? Over 6k minus 12. All right, now notice that this is a subtraction problem. So just remember what we did in the previous lesson. So now I can write this as one rational expression, just like this. But since this is subtracting, I'm subtracting these two numerators, and then this is not a monomial, then I need to be careful. I need to rewrite this, and I'll go off to the side and think about this is going to be 3k subtract, in parentheses, this numerator. And then distribute. And so I get 3k plus 6k, the opposite of negative 6k is 6k, the opposite of a negative 5 is a positive 5. All right? And then I want you to recognize that this right here is, if I can find it, let's see, this right here is, well, okay, I'm sorry. Okay, so this right here, when I distribute it, I'm sorry, this right here, excuse me, this right here is this piece right here. Okay, so try and make these connections between what you have here in this path with what you have here in that other path. All right, and so then combined like terms, this becomes 3k plus 6k is 9. Oops. I'm not sure. I think I may have written something different somewhere. Let me just, because that was 5k. Did I write something incorrect? Yeah, I'm sorry. So I put 6k plus 5, and that should have been 6 plus 5k, right? Okay, sorry about that. So that's 6 plus 5k. And then that's 6 plus 5k. And then that's going to be negative 6 minus 5k. All right, just go back and fix that. So negative 6 minus 5k. And so that's going to be 6 plus 5k. All right, so yeah, you got to be careful when you're transferring things. You can easily mess up. So notice that 3k plus 5k is 8k, and then plus 6. And so that's the numerator, 8k plus 6. And then I can factor out a 2. So remember the next step, once you write this as one rational expression, the next step is to factor and then reduce if you can. So that's 2 times 4k plus 3 divided by 6 times k minus 2. And then these, the 2 will divide out with the 6. And so you get 4k plus 3 divided by 3 times k minus 2, which is the same answer you had here. Okay? All right, so that was number 6. And again, I'm sorry about that. I messed up right here. It should have been 6 plus 5k, and I wrote it as 6k plus 5. All right, so I had to go back and fix it. All right, so that was number 6. Let's look at another one. So number 7. Number 7, we have 9q divided by 3p minus 3q plus 18p divided by 3q minus 3p. All right, now at this point, I want you to start thinking about what would be the easier way to do this. So notice right here, see this, there are two paths I chose. So I did it two ways. I did it this path here, and then I did this path. See, this one looked more complicated, didn't it? So whenever you have more than one term in the numerator, bringing that negative factor up there may make things more complicated if you're dealing with a subtraction problem. So think about what you have and what would be more efficient. But it's important, notice that in your toolbox that you have all these different ways of knowing how to do these problems. So when I look at number 7, notice that's an addition problem, so maybe it may not be that difficult. But I do notice that these two denominators are opposite of each other, and so if I want to add these two rational expressions, they have to have the same denominator. So I'm going to go ahead and factor out a -1 from here. So that's going to be 9q divided by 3p minus 3q plus 18p divided by, and I'm going to factor out a -1. So when I factor out a -1 from here, what you're going to have down here will be -1 times this. So times 3p minus 3q, and always check. -1 times 3p is a -3p. -1 times a -3q is a positive 3q. Okay? Now what I would do here, and again it doesn't matter because it's an easy problem to deal with. You can, and that's a monomial. So since that's a monomial, it's not that difficult. You can think of this as when you add a negative factor, it becomes a subtraction problem. All right, so you could say, well, that's going to be 9q divided by 3p minus 3q, subtract 18p divided by 3p minus 3q. See that? And then you're going to get, now you see how you have two rational expressions with the same denominator. So I can write this as one rational expression. And then I get 9q minus 18p. Once you get to that point, you're going to factor and then reduce. So I can factor out a 9, so I get 9 times q minus 2p. And then the denominator, I get 3 times p minus q, right? And then I reduce. Notice the only thing I can reduce are the 9 and the 3. So the 3 and the 3 is 1, 3 and the 9 is 3. So I get an answer of 3 times q minus 2p divided by p minus q. All right, so that's doing that one path where we notice this. So this path is where you notice that I'm adding a -1 factor, so it becomes a subtraction problem. The other path is this way, knowing that this right here, I can write that -1 factor in the numerator. So that's that other path. So 9q divided by 3p minus 3q plus a -1 times 18p divided by 3p minus 3q. So that's just rewriting this -1 factor in the numerator. But notice that this is a -18p, and this is not that difficult. It's easy because that numerator was a monomial factor. So I get 9q plus a -18p. Oh, I'm sorry, 9q divided by 3p minus 3q. 3p, that's 3p minus 3q. And so notice the denominators are the same, so I can write this as one rational expression. And then the numerator, 9q plus a -18p, you need to remember that's 9q minus 18p. So don't write it as 9q plus a -18p. We all know that 9q plus a -18p means this. And so now you factor, so I got 9 times q minus 2p divided by 3 times p minus q. And then the 3 will divide into the 9 3 times, and that's a 1 here. And so I get 3 times q minus 2p divided by p minus q. Okay? So different ways of doing these things. It's important that you know those ways. Let's do one more, because I am running out of time here. And so we're going to do some more problems in part 2. So let's look at this one real quick. So I have 3p squared minus 2 divided by p minus 3, and I'm subtracting 4p plus 1 divided by 3 minus p. All right, so this is subtraction. Now this is going to be a little bit more challenging, so you need to think about what path may be easier, okay? So think about what path may be easier. So I'm subtracting not a monomial, so this is a binomial. Okay, so it's going to be a little bit more challenging. But I do notice that these two denominators are opposites of each other. The opposite of p is a negative p. The opposite of a negative 3 is a positive 3. So that means the first thing I have to do, regardless of which path you take, the first thing you have to do is factor out a negative 1 from this one. So I get 3p squared minus 2 divided by p minus 3. And by the way, it doesn't matter whether you do it from either one of those or with either denominator. I always do this one. This was always the easiest one to deal with, so that way you can think about what path you want to take. Okay, subtract 4p plus 1 divided by, now remember when you factor out negative 1, if those are opposites, then you'll be able to rewrite this as negative 1 times that. And always check, negative 1 times p is a negative p, negative 1 times a negative 3 is a positive 3. And then now, since that's a binomial, the easier, I want you to think about what the easier path is. The easier path, think about it, is to think of this, subtract a negative 1 factor as adding, as an addition problem. So that becomes 3p squared minus 2 divided by p minus 3 plus 4p plus 1 divided by p minus 3. And now, see this right here, became this. And so then, see, I'm adding these two numerators, so that's going to be easy to deal with. So then I'm going to rewrite these two rational expressions, since they now have the same denominator, as one rational expression. And 3p squared, put in descending order, 3p squared plus 4p, and then a negative 2 and a positive 1 is a negative 1. Okay? And then the next step, remember, is to factor. Well, if you look at this, no matter what you try, you cannot factor 3p squared plus 4p minus 1. Now, if that was a plus 1, then you could. But that minus 1, it's not factorable. So that's your answer. This is it. Okay? Now, let me show you the other path. So the other path is this. So you see, let me go ahead and rewrite this part here, just to show you what the other path would be. So I have 3p squared minus 2 divided by p minus 3 minus, and then 4p plus 1 divided by negative 1 times p minus 3. So remember, the other path is to rewrite that negative 1 factor that's in the denominator to put in the numerator. That's that other path. And so if I do that, this becomes 3p squared minus 2 divided by p minus 3, subtract, just rewrite this over, and the numerator doesn't become negative 1 times 4p plus 1, so remember you have to put that in parentheses, divided by p minus 3. And then notice that the denominators are the same, but before we do that, let's go ahead and distribute. And you can also think of it this way. See that addition, notice when you write this, you could also say, well, I am subtracting a negative 1 factor, so I can go back to this path if I want to. Yeah, you can. See how this right here means the same thing as this right here. Does not matter. But let's just go ahead and distribute this to show you, because that's what some of you may do. So you need to know how to deal with that. So I have 3p squared minus 2 divided by p minus 3, subtract, and that becomes negative 4p, and the negative 1 times 1 is a negative 1. All right, now you see how you're subtracting, so you got to think about the previous lesson. So since I'm subtracting a binomial, then let's think about what that is. I'm going to go off to the side. I'm going to go off to the side, and I'm going to figure it out. So 3p squared minus 2, I'm subtracting this binomial, so you got to put that in parentheses, negative 4p minus 1, and then you distribute. So this becomes 3p squared minus 2, and then the opposite of a negative 4p is a positive 4p, and the opposite of a negative 1 is a positive 1. And they combine like terms, combine like terms, I get 3p squared plus 4p minus 1, which is what we had here. Okay, so that's going to equal 3p squared plus 4p minus 1 divided by p minus 3. So notice the different paths, and so it's important. It's important you know, well, which one's going to be easier for me. So probably this one would have been easier since you were subtracting a binomial. So whenever you're subtracting a binomial, then I would use this path here. It may make things a lot easier for you. Okay, but it's important to know both, so that way you can deal with multiple situations. So that's going to be the end of this lesson. And remember, in this lesson, if I can go back to that first page, is where we were talking about adding and subtracting rational expressions with opposite denominators. So just make sure you understand how to deal with the multiple paths that we talked about. Okay, so that's going to be the end of this lesson.